next 30 minutes, I will show you how NVIDIA Grid can bring amazing graphics to the enterprise cloud. So I will be talking about three different parts. The first one, I will be talking about Grid for VDI, and why you want to have Grid in VDI, and why you need GPUs in virtual desktop and application environments, and what are the benefits, and the products here. The second part is I will show you a couple of grid-enabled solutions. Clearly, this is not just us playing in this space. We have partners and to create these kind of wonderful enabled solutions. And I will show you which solutions are out there and how they work. The third part will be I will show you examples of user profiles and experiences. I tell you about the different user profiles. I show you some videos for the different use cases and some side-by-side comparison between no GPU and GPU accelerated VDI solutions. So by the end of this 30 minutes, you will have seen two things. One, you will have seen the clear benefits of GPU acceleration for VDI. And second, that today we can deliver a true PC experience for everyone anywhere. So let's get started. So before I go into more details, I would like to kind of take a look essentially who actually benefits from NVIDIA Grid. In principle, there are three different main user types. Designers who create very rich visual applications for the models, and power users who actually consume these. And the third category would be knowledge workers, some person like me using more PowerPoint and more Office type of applications. Clearly, at the high end are the designers. And NVIDIA Grid here offers virtually remote workstations, which partially overlap with actually our Quattro Tesla Maximus market. However, this market actually is rather small in comparison to the significantly larger market for knowledge workers and power users. This is the largest untapped market, which are PCs and Mac users in the power user and knowledge worker category, who would like to enjoy the benefits of remoting without any cutbacks in user experience when using virtual desktops and applications. But to give a number, there are about 700 million enterprise PCs in use today. So this is the potential market you can reach with VDI. This is clearly a very large market. So, however, to make this happen, you need GPU acceleration in the data center, which is delivered by NVIDIA Grid. Let's take a look at why we believe that you need a GPU in the data center. So, why a GPU is important for VDI can be actually best understood by taking a brief history in time. So if you remember, in the late 80s when the PC was introduced, we all were very excited to have great computing power at our fingertips. But the visual experience was rather limited. It was text-based, very simple MS-DOS kind of world. This world actually changed dramatically then in the 90s. Microsoft revolutionized the space by giving us a very rich graphical user interface. I mean, the first one was maybe Windows 95. And over the next 2 decades, the experience got significantly better. So now we are with Windows Vista, we got the Aero desktop, now with Windows 8, essentially it's extremely rich graphical user interface. So early on, we first looked at 2D data, then we looked at 3D data, and now we have 3D interactive data, we have 3D design data. People, designers as you will hear today, design cars, airplanes, large skyscrapers, everything, blockbuster movie visual effects, and all with PC workstations with very powerful graphics cards. And this is exactly the reason why we need GPUs in the data center. All these great visual effects have been created on PCs and workstations which have GPUs. The data center so far doesn't have GPUs. CPUs, which are the processors of the data center today or in the past, are very good at many, many things, but they're not very good at delivering very rich graphics. The GPU is actually built for this. And so this is the main reason why in the past until today, VDI has been actually rather limited. So it was limited pretty much to task workers where you would actually have some sort of core application, but anything more rich would require a richer user interface wasn't quite possible. So without a GPU, VDI delivers a very limited experience. So let's take a look what changes once you introduce a GPU, or more importantly, NVIDIA Grid, to this scenario. So what you will see then is that all of a sudden you can deliver a rich graphical user experience to all the user types I mentioned before. At the high end, you have the designers, as I mentioned. These are the people who design your next car, and these are the people who render the graphics for the next blockbuster you will see. These are the people, this is maybe the radiologist who actually will read your MRI results, or the architect who designed the larger world tower here in Seoul. So we can deliver with a GPU and a data set exactly that experience for that type of user group. But that's not all. Then we have the power users. These are, as I said, the consumers of this data. And so what would be an example in that case? So that would be maybe a shop worker on the manufacturing plant floor of an automotive company. He has to look up essentially how to build your next car and to make sure that everything is assembled correctly. This is the doctor, who just got the results from the radiologist and tells you that you don't have to have surgery and you will recover without any problems. And it shows you the little image showing why this is the case. But it's good to also you who want to kind of edit your latest vacation videos with Photoshop. And so every one of us is actually a power user. Further down, knowledge worker, I mentioned that's maybe someone like me giving a presentation here. PowerPoint, for example, is a DirectX 9 application, so it really requires the special effects going from one slide to the next. That requires graphical GPU acceleration in order to have a very smooth transaction. But also even more, Google Earth or Google Maps, these are all applications which benefit from GPU acceleration, or video streaming, you watch YouTube or any kind of other multimedia content. So what I want to kind of show you here, that basically with the help of a GPU, all of a sudden you have access to essentially all user types. You're not limited anymore to the task workers alone. And in fact, task workers are just the smallest piece. And so you can deliver essentially VDI to everyone. So today it's possible to deliver a true PC experience to everyone and anywhere. So you can maybe mention that this was all talk. And here's actually an example showing you exactly the difference. So here's a side-by-side comparison of the SolidWorks. On the left-hand side, you have both are live video captures of the VDI session. And on the left-hand side, you have the no GPU version. On the right-hand side, you have the GPU accelerated version using an NVIDIA Grid K1. So you can see on the left-hand side, clearly the sort of this particular model, it works. But the experience is rather limited, right? So if you compare the level of detail, it's quite different. It's also not as smooth. But I would say, if you just need to look up that model and find out, maybe how to assemble that car, and you need to spend just a few minutes to find out everything is assembled, that probably is fine. However, if you're a designer and you need to actually design this car, and you get this no GPU kind of experience, you will be very, very frustrated. In contrast, if you look at the GPU accelerated version, you will see the experiences, just like on your PC workstation. In fact, I was actually talking to a designer, and he couldn't tell the difference whether this was a VDI delivered solution or it was actually running directly off his workstation. Actually, I invite you later on today to go to the demo zone, and so here we have a couple of examples where we have a comparison of a workstation right next to a VDI solution, and you can see with your audio can experience with your own hands and eyes that this solution is here today. So again, all this is delivered in a BI session from the data center and with our Diebel technology. So let's take a look further. So now I have shown you that you can deliver these type of solutions, but let's take a look what's actually behind it. How do we do this? There are clearly two parts to it. One is our VTX software combined with our hardware, which is actually very important. These two pieces are very, very important. It's a complete understatement if everything comes only out of the hardware. The software is very, very critical to utilize all the benefits of our hardware. So on the software side, we have graphics visualization technology as well as remote graphics technology, which empowers the VTX solution. And obviously, you need to have hardware to accelerate. Otherwise, there's nothing you have nothing to accelerate on. So let's take a closer look here. So essentially, there are four different pieces which are important to deliver a GPU-accelerated NVIDIA solution. On the very bottom, you have our NVIDIA GPU, very similar to a workstation as well. In the server, however, the next layer will be a hypervisor. Here we provide an NVIDIA grid-enabled hypervisor. It's very important to note here, we are not a hypervisor company. We only providing special software for the hypervisor to enable this virtual PI experience. So we work together with industry standard partners like Citrix, VMware, and Microsoft to make this happen. The next level is actually the NVIDIA driver itself. Very similar to the workstation, this is actually a combination between the NVIDIA driver and the NVIDIA grid GPU. This is the magic essentially where you get the full graphical experience out of it. The parts which are kind of shaded in the or highlighted in green here, these are the solutions which can be added for anything if you want to deliver it through the data center. So just to underline essentially how important the driver is, NVIDIA has actually more than half of NVIDIA's employees are software engineers. So it's actually, we should call ourselves actually a software company rather than a hardware company, just by looking at these numbers. So you can see that there's a lot of important parts in the NVIDIA driver itself. It is not only functionality, but we spend a lot of time for optimizing essentially for different applications to deliver a very, very great user experience at the end. And then a big part is due to the driver. So whenever you use any type of VDI solution, the first question you should ask yourself, are you using the NVIDIA driver? If you're not, then basically you're getting only half of the experience, or even less. And the last piece is the NVIDIA grid-enabled virtual desktop. Clearly, you need to remote the solution back to the client, and we help, we add also software in that area to reduce latency and improve the user experience. So again, here are these two different parts I was talking about before. The software on one side, the GPU or hardware on the other side. So let's take a close look at the hardware first. That's actually the easiest part. Okay, so NVIDIA Grid has two different cards, NVIDIA Grid K1 and K2. These are actually targeted for very different use cases. K1 is targeted, is our core GPU entry-level Kepler GPUs, and the K1 solution is targeted for user scalability. So if you want to go many users onto a server, you would actually pick a NVIDIA Grid K1. In order to do this, you have to have significant or sufficient memory. And so if you compare the memory between the K1 and K2, you see the K1 has double the memory of K2. And the reason for this is in order to load more users onto a server, you need to have sufficient frame buffer for every single user you want to have. In contrast, K2 is targeted for designers. These are the people who want to have a dedicated GPU that needs a very high performance GPU. So these In K2 you have two high-end Campbell GPUs. And if you look simply compare the number of CUDA cores between K1 and K2, you can see that it's about 8 times more powerful than a K1 GPU. Also, K2 has extremely fast memory. So instead of using standard DDR3 memory in the case of K1, we're using DDR5 memory for the K2 solution. And this is all to deliver a very, very high performance system in your K2 package. So I talked about user scalability a little bit. Maybe you're interested in how many users you can pack on these different parts. So K1 essentially in something called pass-through in a dedicated fashion, since it has 4 GPUs, you can deliver 4 up to 100 users. And 100 we showed, I think 2 years ago at GTC, we showed a demo of 100 API sessions using NVIDIA K1. In contrast, for NVIDIA K2, since it's targeted to a more dedicated high-performance user, and in pass-through mode we have 2 users, and given the fact that it has less memory at the high end, you will also be able to serve fewer users. But the whole point of K2 is not to have user scalability. The point here is to deliver high performance to a few users in comparison to K1, where you want to deliver a graphical acceleration for maybe many people. The last part I want to point out here is the software support for these 2 solutions. Both of them support OpenGL 4.3, which is the latest version, as well as DirectX 11. And out of the box, it will support, or it is supporting, our GridVGX technology, which will be released later this year, I think first in Citrix. But you don't need to buy new hardware. All Grid K1 and K2 parts support this immediately. If you use these cards in pass-through mode, also in principle, you could also run CUDA on them as well. Well, I should add one more thing here. Of course, this solution is right now available through Dell, and so shipping, I think starting, or it has been shipping for a few weeks now, and you can get this complete service solution together in the Dell PowerEdge R720, and R720 takes 2 K1 cards and 4 2 K2 cards. So if you want to buy the solution today, it's ready from Dell. So I talked about first about the hardware portion of it. Now it's time to go over to the software portion of it and take a closer look here. But before we actually dive deeper in how we use the software, I want to give you a quick overview of the purpose and the benefit of VDI, and then basically give you a quick tour of how a typical data center server looks like today, and how you would integrate that afterwards, our GPU, and what changes once you integrate the GPU. So there are quite a few synonymous terms for the virtual desktop, and some people call it VDI, virtual desktop infrastructure. Other people talk about HVD, hosted virtual desktop, and maybe a different person will call it design virtualization. But all these terms are essentially identical. These are talking about the same thing. The main purpose of a virtual desktop is to replace your physical desktop or laptops with a virtual desktop server. There are clear, many different kind of benefits, and everyone picks a different one for their liking. But I will list you just a few of them. So, for example, it's great if you want to move your compute resources closer to the large data in the data center. So, for example, if you're working on a large special effects movie, and you have your data, you can store now your data in the data center instead of moving down to your desktop or your other infrastructure, and you can process right there. For example, I think transformers, these models, they're massive, so very, very large data files. And basically, keeping them in the data center is a great benefit for the person using it. It also has a great security aspect to it, right? Because now the company doesn't need to worry anymore that basically you use your laptop or wherever you want to store your data on. So it's a great benefit in terms of security. And from an enterprise perspective, it also adds additional manageability. So now the IT manager can much closer monitor or use certain OS images to manage them more closely. And also, disaster recovery becomes significantly easier. You might not even know when a certain server goes down, certain images replaced. So you can, the IT administrator can do this pretty much on the fly. You wouldn't know this. The last part is clearly it is also a way to use your resources a little better. That you don't have idle software or hardware lying around or sitting. If you don't purchase unneeded resources. But I think we believe maybe the most important part is user flexibility. So now, using PDI, you can access or you can work essentially from any device, anywhere, at any time. So I think we believe that user flexibility is maybe the most important aspect of PDI. So let's take a look at how a typical server is made up. A typical server has, in terms of the hardware, CPU, memory, storage, and a network. What happens next is the hypervisor gets loaded on top of it, and the hypervisor virtualizes all the physical resources in terms of a virtual CPU, virtual memory, virtual storage, and virtual network. And since it's a hypervisor, on or in that virtual machine, now you will load your guest OS. The guest OS has drivers to access these virtual resources, and on top you will have now your applications running and doing what you want to do in that particular virtual environment. And since it's a hypervisor, you can now actually load multiple of these virtual machines on it, and the hypervisor gives every virtual machine just a little chunk of the resources you have available. The key part in this is to deliver this solution then to the final client, you need something called like a PDA, a virtual desktop agent. That agent captures the display and delivers them through over the cloud to the client and your desktop. And then it's displayed at the client itself. So let's take a look who the players who are providing the different solutions in this scenario. So in terms of the hypervisor, maybe the most dominant player here is VMware with ESX and or vSphere. Other solutions are Microsoft Hyper-V, and you have Citrix Server, Red Hat has a solution, there are other open source hypervisors. And in terms of your guest OS, you have maybe the most dominant ones are Windows 7 and 8. Maybe some kind of most people might also try to work with Linux, but I think the dominant ones are Windows solutions here. In terms of your PDA, the solutions are here. The dominant one is Citrix Zen Desktop, and it's actually quite interesting. Probably the most used combination is to use VMware as the hypervisor, and then Zen Desktop as your virtual desktop agent, because both companies they came from different spaces, and the dominant player in the remoting is Citrix, whereas the dominant player for hypervisors was from data centers actually at VMware. But there are clearly other solutions. You have Microsoft IP, HP as a solution, IBM, and maybe ENC. In terms of the protocol, there are also a couple of choices. Citrix uses ICA, what they call it HDX 3D Pro right now. VMware uses PC over IP. Microsoft uses RDP, but there are many different kind of ways you can do remoting. So this is a picture of the server today without the GPU. So now let's take a look what changes once you enter a GPU to it. Essentially, you have three different ways you can enter or you can add a GPU to that server. The first one is called GPU pass-through. It's a one-on-one dedicated GPU per user. In this case, your server is virtualized in terms of your CPU and the other resources, but not virtualized in terms of GPU. One VM gets one GPU, and it's a dedicated value. The second step to start to virtualize the GPU is called shared GPU. This is software virtualization, and while it works in certain cases, it's not the right solution for everyone, because there's certain kind of limitations. For example, I think VMware's ESGA solution currently supports OpenGL 2.1 versus OpenGL 4.3. But clearly, if you and your software stack or your particular application doesn't need to use this, I think software virtualization actually works quite well. The one I want to talk about here in more detail is called Grid VGX. This is true hardware virtualization of the GPU through the NVIDIA Grid VGX technology. And I will show you in a second how that looks like. Again, there are a couple of synonymous terms. So whenever you hear NVIDIA Grid VGX technology, or you hear VGX GPU hypervisor, vGPU, virtual GPU, or hardware virtualization, all these terms essentially mean the same thing. And clearly this is coming very soon in a few months. So how does the feature changes on what I showed you earlier on? So the first thing essentially, we will be placing the GPU at a hardware level into the server. The next thing is we will be adding our Grid VGX technology in a hypervisor. And since we have the VGX technology in a hypervisor, you can see in the virtual machine now in the NVIDIA graphics card. Before you had actually engineered virtual graphics card and if you use, for example, VSGA. But because you have the Grid VGX technology, now you can see in the virtual machine an actual NVIDIA graphics card. That means you can now also use our NVIDIA driver. Remember what I was telling you earlier on about the PC and the workstation? Whenever you have the combination between the GPU and the driver, you get benefit here. And this is actually the most important part. You can use now in this mode the NVIDIA driver in the virtual machine and get the true benefit of our package, while you can still virtualize the GPU at the hardware level. And finally, then there's a VA solution where you also add certain software to it and to increase the remote. So let's take a look essentially how the VGX technology delivers this great performance. I think there are two steps to it. And the NVIDIA driver talks through the VGX technology to the GPU and sets up the state, meaning essentially it allocates a certain frame buffer, certain memory addresses for every virtual machine. And in the second step, then the NVIDIA driver can talk directly to the GPU and render the desktop, the physical windows. And then the driver can actually pick up the state and directly without kind of being passing on. So it's not an API descent model. So the driver has full, it appears that the driver has full access to all the NVIDIA and grid hardware through the VGX technology. And then, because we have now virtualized the GPU, you can completely virtualize with many different kind of virtual machines that we have. You can deliver the GPU in different pieces. So this technology will be available very soon. I think Citrix will hopefully release, and it will be available, I think, with the next Citrix Windows and server. So this brings me to who are the players in the solution. Clearly, this works with our K1 and K2 part. The current hypervisor that supports this is Citrix and server. We need the NVIDIA VGX software from NVIDIA. I think this will be available on our website once it's released. You can use our standard driver, which is the key part in order to deliver this very rich experience of solutions. I showed you how we add a GPU to a current server which doesn't have a GPU. And I showed you some great examples. I showed you different user profiles, a designer, the power user, the non-worker, and I showed you an example of the SolidWorks example, and he showed you that basically VDI or true PDC experience at the even highest level of performance is there today. But I can see that you might say, I'm not a SolidWorks user, I'm actually not a designer, and I'm more of a power user or knowledge worker. I'm using Photoshop, Google Earth, or PowerPoint, so how do I benefit? And so let's take a look how you might benefit, even if you don't want, if you're not a designer. So this is an example of Google Earth. It's a fly to our Silicon Valley area. On the left, you have the traditional VDI solution, which only has uses a CPU and no GPU. You can clearly see that the rendering is significantly slower than if you use a completely GPU accelerated version on the right-hand side. And you see a clear difference, even for a person using Google Earth. So this demo clearly shows the benefits of GPU acceleration for power users and knowledge workers. And the best thing, all this is available today in NVIDIA as an inside of the Dell PowerEdge R720. So I hope I was able to show you that a true PC experience for everyone, everywhere delivered from the data center is available today. Thank you.